Hi, my name is Sandy, and you're at the Ancestry Roads webcast where we talk about Appalachia. We discuss all types of topics of Appalachia. And today we have a pretty important topic. This is one that we generally don't dig into as much, but as a viewer request, we were asked to discuss the environmental impact in words and terms that we can understand from the train wreck that happened around East Palestine, Ohio earlier this month. So to do that, because this is going to be a topic that will last for a while here. This is not going to be just a one and done topic. This is going to be a topic that's ongoing in the northern part of Appalachia. So I brought with me somebody who is going to be an expert with this, and he is a West Virginia University professor, and that is Dr. Michael McCawley. So thank you, Doctor, for joining us today and also discussing with us a highly technical topic and also something that is pretty reactionary right now.
Oh, thanks for having me here. This has been an interesting topic. I've been getting a lot of questions coming into my office. So
I can imagine, especially with West Virginia and Ohio and Pennsylvania, all right near where this happened. Let me give you a little bit of background about Dr. McCawley, because this makes sense why I invited him here today. So he received his bachelor's degree in zoology from George Washington University, as well as master's in environmental engineering from West Virginia University, and a doctorate in environmental health from New York University. And the environmental health is going to tie into what we're talking about today. I do want to point out that Dr. McCawley has also spent 27 years as a public health officer with the CDC and also with OSHA for occupational health. It's pretty important that those two areas also, along with the EPA, are probably in discussion with what's going on with the environmental impact. So again, this is fabulous that you joined us today. I want to point out too that you've been teaching at the West Virginia University since 1979, I believe.
Yes, I have. Continuously since 79. I actually started in 75, then went away for my PhD.
And came back. So are you in Morgantown right now?
I am.
So yeah. You're up northern West Virginia.
Yeah. I'm not a native West Virginian. I was born in Washington, D.C., but I got here as soon afterwards as I could. So
I thought you were going to say you got here ASAP, so that makes sense. So from my West Virginia ancestors, we thank you. Well, let me give you a little bit of background for those watching about what this topic is, and then we're going to dig into some questions and find out just the facts. This is not a political webcast. We do not talk politics. We do not share sides. So during the webcast, we do sometimes bring up your comments. If they are political, they will not appear in our webcast because we want to remove as much rhetoric and as much extras as we can and just get the facts. So what are the facts? So on February 3rd, 2023, a Norfolk Southern freight train carrying hazardous materials derailed near East Palestine, Ohio. The cause is believed to be a mechanical issue with an axle on one of the 150 cars, 151 cars, and 51 cars actually derailed. So there were about 140 were loaded and 9 were emptied, and 51 cars actually derailed. The train burned for about 2 days before a controlled burn was conducted on several cars. 11, and I want everybody to pay attention because this is really the hot topic of what this webcast is about. 11 train cars dumped 100,000 gallons of hazardous materials at this derailment. And this gives you a brief list from the EPA of some of the chemicals and what was in these cars that was hazardous material. There were other cars that had other types of materials, but we're really talking about the hazardous materials on this webcast and the environmental impact. So then, Dr. McCawley, I guess I have two different avenues to go here that we got to try and squeeze in. First, we have the airborne contamination,
Mhm.
and then we also have, I guess, the groundwater contamination. Would you agree that those are probably the two avenues?
Those are the two basic ones that we'd be most concerned about, really.
Okay, so then let's start with the airborne.
Yeah.
So we had the airborne contaminants. How long are they in the air, and how far are they going to
Hmm.
go? They're not. Are they going to go to California on a wild wind, or they stay pretty
Yeah,
close to where
that's a really interesting question. So um, I teach this kind of subject. And of course, where I start off with my students is I say there are two main things that you have to be concerned about with any air pollutant, and that is the meteorology, the weather that's
Hmm.
going on in the area, and the topography, which is the terrain and the shape of the terrain in the area. And what we have here in this portion of the country, the beginnings of the Appalachians, is we have a variety of terrains and
Yeah.
shapes of terrains that we're dealing with. And so we have a variety of possibilities of what can happen with the air pollution. We're also in an area historically that was notorious for some of the air pollution episodes. So we're about, I think, 100 to 150 miles north of Donora, Pennsylvania, and all of the history books and all of the air pollution books, when they start talking about problems with air pollutants and episodes of terrible air pollution problems, talk about Donora, Pennsylvania. And the reason why they talk about it is because of the terrain and the
Mhm.
weather in this area of the country. So you can't divorce those concepts and those issues from the issue of what gets spilled and what goes up in the air, because that's going to affect a lot of things.
So it's just if it goes up, you've got the terrain. You could hit across or open up in the weather
It,
of
it,
that particular day in the next couple days.
yeah. So, well, let's talk about the weather first,
Okay.
because there are two complexities in the weather that people have to understand. First of all, if you put air pollutants up in the air, they're going to start spreading out with the wind. So the wind can come along and blow and sort of mix them around, spread them out a little bit. When it spreads them out, it dilutes them, but
Mhm.
it also carries them away to someplace else. Unfortunately, it's diluting as it spreads. That's one kind of situation and one kind of way that air pollution can move away from the site where it's been generated. There is a second method, though,
Oh.
that you can't ignore. And that is, if you ever watch the weather maps on the news, you'll see these lines that run across the weather map with either a triangle or a half moon on them. And the weathermen will call these things fronts.
Mhm.
Um, and if you don't understand meteorology, you think, well, that's kind of complex. What's a front? And a front is actually something very simple, and I think most people can understand it. A front is just a wave, like a wave on the ocean, except this is a wave on the air. And as it moves along, like a wave, it'll pick up what's lying there and carry it whole and entire along with it.
That's a great explanation.
And it doesn't dilute it. So if you're at the beach sometime and
Yeah.
you see a wave dumping trash onto the beach, it didn't get diluted from where it came from. It
Hmm.
got picked up by the wave and dumped there. And that's what happens. That was in fact my master's thesis. I was in a little town in West Virginia called Mount Storm. And Mount Storm is not quite in the middle of nowhere, but you can clearly see the middle of nowhere from there. And so one would not expect to see things like ozone. Ozone's due to heavy traffic. If you ever go to Los Angeles, you'll see smog.
Mhm.
Smog is basically made of ozone as a primary constituent. And you need a lot of automobile traffic to make the stuff that makes the smog. Mount Storm had terrible problems with smog. And smog in some place like Los Angeles rises to a peak about noontime because not only is it made of what comes out of the tailpipes of the cars, but it's made due to the energy of the sunlight. So the sun shines down, causes a reaction in the gases that are coming out. That causes the ozone. So one would expect that the ozone peaks are going to be around lunchtime. Poor Little Mount Storm was getting the same kind of levels of ozone peak someplace like Los Angeles had gotten. Not a lot of traffic, a real mystery. And to add and deepen that mystery, it was getting those levels at midnight, not at noon. And the thought was, well, wait a minute, this ozone should be caused by sunlight. Even Mount Storm doesn't have a lot of sunlight at midnight. And when we were up there studying this, we could see these peaks arise. And at the same time, we started watching the weather maps. And sure enough, here came one of the waves, one of the fronts passing through the area. And we watched where it passed through first. So it might have passed through, say, Cleveland or Detroit or St. Louis. I mean, it was coming from long distances in some cases. And in fact, you see this now all of the time, now that we know to look for it. And so if there is a lot of pollution in East Palestine, it can get diluted before it reaches West Virginia if it's just being blown by the wind. But if it's a front coming along, that wave is coming along and picking it up, you can dump it kind of whole and intact someplace else.
So how long, if we just look at East Palestine and let's say a front or weather didn't happen, how long do chemicals stay airborne in general?
Well, the gases, so they could stay airborne for a long period of time. The 𝗪𝗪𝗯𝗰𝗵𝗶𝗄 incident, which was really caused by local pollution coming up into the air and being trapped down in the valley, but that went on for 2 weeks.
So then now if we add in the weather and a front,
right,
that could be
so one of the things that the front's going to do actually is tend to take the pollution out of the area. That's good news for East Palestine, not necessarily good news, say, for Pittsburgh.
Yeah.
If the front is heading in that direction. Not good news necessarily for the northern panhandle of West Virginia, because there you're starting to run into the other problem, topography, the terrain. Yeah. So you dump this pollution in a holler, and holler is enclosed usually. Yeah. It's a small valley, small area without a lot of airflow going through it. Dump it down there, it's going to be trapped down there and can stay trapped for quite a while.
I was going to say, there's not a lot of movement of air down in a holler. I've been in them a lot in my lifetime. There's just not.
And people in West Virginia realize this pretty well. I mean, you see fog in the holler all the time, right? And how long does the fog persist? Well, the fog will persist until it gets burned off. And the burning it off, quote unquote, burning it off, is really just the sunlight causing the air to mix things up. And that's the air movement that takes it out of the valley in many cases. So it also takes off that top lid called an inversion that sits down on those valleys. So if you look in a holler at the right time of year, at the right time of the day, it looks like the fog is not going anywhere.
Right.
It doesn't seem to be lifting off. And that's because this inversion is a layer of warm air sitting on top of a layer of cold air. And the stuff that's down in that holler doesn't rise through the warm air because the warm air is warmer and you can't lift stuff unless the air that you're trying to lift is warmer than its surrounding. Kind of like the little bags with the candles in them. You ever see the movie Tangled where they're letting off these bags? And, being an air pollution person looking at that, I was going, well, it's a good thing they didn't have an inversion for this because the bag was going anywhere. I'm a buzzkill
for a cartoon. Well, so if I went to East Palestine today, would the air be contaminated? You think?
Okay. So now we're starting to move into one other area.
Okay.
Generation. Okay. So you remember you asked, in fact, is it air and is it water? Well, it's air and it's water and it's soil.
Yeah.
Okay. So this stuff is getting in the soil as well, which is how it eventually gets in the water. But when it gets in the soil it's a material that will, in fact, evaporate. So if you were, say, to spill a 5-gallon drum of gasoline on your lawn, you'd smell gasoline on that lawn for a while, right? And that's because it's soaked down into the soil, and it's coming up out of the soil by evaporation, because gasoline will evaporate slowly off of a surface. And so now it's getting into the air as a quote unquote vapor. We tend not to use that term technically. We'll tend to call it, it's either a gas or it's a liquid or it's a solid. But a vapor, people can't agree on really what they think that is. So we'll call it a gas that evaporates off of there. And you can smell the gas. And it can evaporate over a long period of time, because as it moves out of the soil, if it's soaked down, it's going to tend to wick whatever soaked deeper up to the surface, which evaporates, which goes into the air, which causes more wicking, which causes more evaporation, which causes more into the air.
So when it comes up into the air, is it still hazardous?
It is still hazardous. Yeah, and may change. Okay, so now let's talk about change. There's a fire. Okay.
Well, and that'll be, I'll warn you in advance. What is probably not appropriate right now, but I'll warn you in advance. The biggest question was the fire and the controlled burn. So I'm sorry, I'll let you continue.
Yeah. So let's take a simple example. Okay. Take a log, throw it on the fire. After a while, it's not a log anymore.
Yeah.
Right. It's changed. It's changed from the solid to a gas, essentially. And a little bit of ash left behind. And the chemicals inside have changed. So if you want to get a chemical reaction going, when you were in high school chemistry, you put a Bunsen burner underneath the test tube, right? And things started changing. Things started happening in that test tube. And that was the chemical reaction. And so the fire creates the energy for chemicals to react. And they're going to react. And they're going to create new chemicals. And so whatever you spilled is not necessarily there anymore once it gets in the fire. It could be something that's much less toxic. And it unfortunately could also be something that's much more toxic.
Oh, so for these, let me see if I've got this right. So for the chemicals, hazardous materials, there was vinyl chloride, benzene residue, and butyl acrylate.
Right.
And
all those will burn.
And they will burn. All three will burn.
Yeah. And
is that why they decided to do the controlled burn?
Well, if you don't do the controlled burn, you have to get in and soak the stuff up, which is difficult to do, first of all. And secondly, takes a long time to do. So if you want to get rid of it quickly, then burning it is one possible way of getting it to quote unquote evaporate, go up into the air, take it out of the soil, take it out of the ground where it's soaked in, and get rid of it, get rid of whatever it's spilled on. So there's a certain sensibility to thinking, let's burn the stuff and get rid of it. The difficulty that goes with sensibility is that what you get is not what you had before, and it's hard to predict what's going to be in the air now.
That was going to be my next question. Do they know what they get? And
well, they can monitor and maybe tell you somewhat what they've gotten afterwards. This is not a typical EPA sampling situation, though.
Because these are three different hazardous materials being burned at the same time.
Yep.
And that's got to be tricky.
That can be very tricky. And the temperature is not uniform when you burn it. So you could have a hot spot here, a cold spot there, relatively speaking. A hot spot could be 1,000 degrees and a cold spot could be 800 degrees. But it's going to be different temperatures in that burn. And what goes on is going to be very temperature dependent, as well as how well mixed these things have been. So have you got 20% of this and 80% of that? They might mix to form one chemical. If it's 80% of this and 20% of that, then they're going to mix maybe to form a different chemical. And if they occurred at two different temperatures, again,
you could have something different.
Some possibilities, yes. and the prediction can be difficult. So you tend not to be able to predict, but you say, well, we're just going to hope that it blows away quickly and doesn't concentrate, and that nobody downstream has a problem, and that there's not a wave passing through the area at that time to move it on along.
So
Remember, the good side of the wave is that it'll move it out. The bad side of the wave is it'll put it somewhere else.
How long do you know how long the control burn was? Or how long typically? I guess what I'm asking though is not really that question. Let me backtrack. What I'm asking is if this control burn continues for how many hours or a day or two, that's still bringing things up into the air and into the ground and carrying it away with a front.
Right.
And the EPA is there monitoring it constantly. They probably have a large group on the ground.
Hopefully.
How do we get away? How do we get past this environmental impact?
Well,
the immediate one, not long term, the immediate one.
Yeah. Okay. So first, I'm a public health person.
Okay.
And for me, public health is the same word as prevention. Or if you want, the fence at the top of the hill, not the ambulance at the bottom of the hill. So we're very interested in stopping things from going bad before they start. And so as a public health person, I would say prevention is the best thing you can do. Don't have a traffic accident. You don't have to clean up after it. And there are ways to prevent things.
And that's probably, I typically ride the rails instead of flying. So this was an important topic to me too, because I've been on rails where I've had to on Amtrak where you have to sit on the side if there's been a minor derailment, not anything like this, and you have to wait and go through. So you do question, I guess, rail safety, and we don't really talk about that a lot in America either. I wonder that I know we're slightly off topic with that. That is a topic that I'd love to have you come back and talk about, because I think this is the prevention is really important.
Yeah, and I mean, there's a whole history of rail accidents in the folklore in Appalachia, right? Ever sung Casey Jones?
Yep.
Right. So we used to talk about it all the time. Planes and automobiles get a little more attention now. Whether they're more dangerous or less dangerous, that's another topic for another day also. So yes, I mean, there's some inherent risk. That's what really we talk about. We don't exactly say danger, because danger is another step farther down. That's what happens when the risk comes true and how it ends up coming true. But risk is just, is it going to happen? And is all hell going to break loose at that point?
And I feel like for the residents around East Palestine, that they woke up or they heard this, they see the plume, and visuals are very scary. You see this large plume and you immediately start thinking, and then we hear that some farm animals or some fish, things like that, are starting to die.
Yep.
These are all real life. These are not that's not folklore that's happening with that, right? That we do have some wildlife that are dying because of these chemicals.
Oh yeah, it's quite possible. And what happens is, of course, the concentration, something like this, where there's a spill and then a smaller fire than the controlled burn, that may release chemicals kind of more at ground level, and they're going to be more concentrated perhaps at ground level, because the higher you get them up off the ground. That's why we had tall stacks along the Ohio River valleys, right? There was all of this conversation several decades ago about the power plants, the coal-fired power plants in the Ohio River, and how much pollution that was exerting in these smaller communities, in these smaller areas, in the river valleys, along the Ohio River. So they raised the stacks up, and that cured the local pollution problems and moved the pollution to somewhere else.
And that's kind of interesting. You move the pollution somewhere else. And I feel a little bit with this, when a front comes in, we're moving in, but it's nature at that point when a front comes in.
That's right.
So I guess if it's, is it in our water tables right now? So the chemicals are in the ground.
Yeah,
in the water table?
most likely. There's an aquifer that runs under much of this area, and it's going to be fed by surface waters. We call them surficial, making an adjective out of the word surface. But these surficial waters usually have contact with the underground water supplies, because the underground waters are essentially underground lakes and underground rivers. So they act just like the lakes and rivers on the surface. They flow, they can get contaminated. We worry about all sorts of things and how we treat those. If we go a little farther north to Buffalo, the Department of Energy or somebody buried some radioactive waste in one of the aquifers that's leading towards Lake Erie.
As a test, or
no, just
that's a good place to bury it.
Thinking they were going to get rid of it by
Wow.
Yeah, and so they're spending a lot of money trying to stop that from flowing into Lake Erie and cleaning it up. So those kinds of things do happen, and we make mistakes. We go in and we clean things up, and it becomes expensive.
That's going to be, I guess, the other question. Where is this going around the waters here? Or what rivers and lakes, the Ohio and the Monongahela, how far can it travel in the water? We heard about the fronts with the air. So how far can a substantial amount, I guess, of hazardous materials travel in water?
Well, as it travels in water, again, it's kind of like the first situation with the air, where you throw it up in the air and the wind comes along and blows it, mixes it up, and dilutes the pollution in it. The same is kind of true in the waters. If you have a source coming in, the flow of the water will tend to dilute it some, but some of it's going to get into the aquifer, some of it's going to be on the surface of the waters. And we know, it's just a movie that was made about the Teflon getting into the waters in this area, right? And there's an example of where can it go and what can it do. We, watch the movie, find out.
Yeah.
That's a pretty accurate technical movie for the most part. And so there are things that we have to be concerned about. So if it's getting into the aquifer, then we have to worry about our well water.
That's the other. That's how, just where you are most, I know that some of the outlying, more remote areas in West Virginia are on well water.
Oh, yeah.
When you're in the city, of course, you're going to be on the city sewer, things like that. But it can't, how far could it travel? If I was living, say, outskirts of Charleston, West Virginia, that far south, and I was on well water, could it reach me?
Okay, so the aquifer that we're talking about for this area, when I say aquifer, it sounds like this little pond of some sort. The aquifer runs from Pittsburgh to Washington, D.C.
Oh, so instead of, I was taking a north-south, and it's more east, and more going towards the east.
Yeah.
Okay, so then would that go through towards, I'm just supposing, like over the Shenandoah towards the Washington, D.C. area?
You're potentially going to find it anywhere in the aquifer. That has been a big controversial issue when they first started doing the unconventional natural gas drilling operations, the horizontal drilling and all of that they were going to somehow or other leak into the aquifers. And that if they leak into an aquifer in Pittsburgh, they could see the pollution in DC.
Interesting. I know that is the natural gas drilling is such a large topic for some of my current relatives that did sell, the mineral rights.
That's one of the other popular questions that I get to deal with.
So if I was living in East Palestine, they did evacuate for a short period and then people came back. So do I go on with my life and not worry too much about the environmental impact as of today? Or do I go on with my life and realize there's a chance there is a larger environmental impact, maybe in especially those that are like children or the elderly?
Yeah, well, I had a friend who did quality control for industrial processes,
Hmm.
making sure the process goes the way it's supposed to go. He had a sign in his office that said, "In God we trust, all others we test." And
See, yeah, I get that answer. I understand that answer.
yeah, and so when there's a spill like this, and the chance that it got into an aquifer, and the chance that it might be in the well water, um, doing occasional testing or having somebody say, "Yeah, we're going to set this up, so we're going to come through and do spot checks." They you don't have to test every single well to see what the risks are, and
Just a
it's the
sample.
risk that we talk about here.
Will,
Uh,
will the EPA be doing that for a long time now, you think? Or is it something that I could, as a homeowner or landowner, request?
well, certainly you can request it. The EPA takes requests. Do they
Okay.
respond to all of them?
Hmm.
Maybe not. And as I said, to check to see what's really going on, it's maybe more like a spot check of
Uh-huh.
areas. You take a sample and see what's going on in that area and sort of relate it to the surrounding areas. So you don't have to go to everybody's house, get a bucket of water
Want to
out of
go
their
through each
house,
one.
then go to the next one. But
Do they
um,
publicize those spot checks? Do they, or are they just kept in their system, or are they public knowledge?
Usually, well, it's the government. It should be public knowledge,
Yeah.
and they should be able to tell you that. And I know in some places, for instance, when talking about the drilling operations that went on, people found that their aquifer got contaminated, and so they were bringing in water trucks essentially, and putting up these water trucks in people's yards, and they were drawing the water out of the truck and replacing it as it went for long periods of time, because it can take the aquifer a while to clear out. I've noticed that my colleague 𝗪𝗀𝗯𝗵𝗶 has been answering some of these questions as well, and he's really the authority on the water. Or I usually take the air stuff, but
Mhm.
yeah, we kind of tend to agree and have worked together, answering questions for various communities all across the region in the Marcellus Shale, where people were saying, what's the issue here, and how long could it be an issue? Uh,
Mhm.
and it depends upon how fast the water's fallen, how high the contamination was when it got into the system, how many people have drawn from it. Just it's a difficult question to answer in theory. You kind of have to answer it empirically, which means go out and collect data and respond to people. And so I would hope and really expect that Norfolk Southern is going to be addressing those issues and going to be talking about testing the water supplies and making sure over the course of time that if there was some contamination that got in at some point, that it didn't make its way somewhere else into the aquifer.
Well, that's a good question too. A little side question. Do you know, when something like this happens, the companies that caused the accident, in this case Norfolk Southern, are they the ones that are required to step up and do the majority of the testing? And I guess this is a start into the remediation as well.
Yeah, so the remediation is really a program,
Hmm.
and most people want to see as many people involved in that as possible. So, for instance, if we go back to the natural gas
Hmm.
drilling operations, people wanted to see both their government and the companies somehow or other working together to take care of this problem, saying that if there was a leak from one of the pipes that a company drilled, it had the responsibility to make sure it got cleaned up, but they also want the government to double check
Hmm.
that somebody just didn't tell them, "Oh yeah, we've done it."
We did it. So then, at this point, are we in remediation for this particular
Yeah,
drilling?
you're certainly. I mean, from the moment the accident happens and there's the spills and the fires and all of that, you're in remediation, and you're probably in remediation for a fair period after that if we're to take any of these other things that have happened.
So the control burn, that was probably going dive first into the remediation. Let's control this and
let's get it cleaned up. Let's keep so the control burn is going to also help keep it out of the water. So put it up into the air. It does sort of disperse it around, and so it doesn't get into the water, but it got into the air, and it may be it may have been transferred to somewhere else and somebody else's problem at that point.
Well, let me ask you this too. So if it gets in the air and it goes to, say, Canada, and then does another country come to us for remediation on any issues that may occur? Or they typically, that sounds like a lot of red tape.
It is a lot of red tape, but people do, in fact, complain about it all of the time. There was one big, if you're old enough to remember this, you don't look like you're old enough. I don't see any gray hairs. There was something called acid rain a few years ago, a few decades ago. And the problem was, if you remember the tall stacks along the Ohio River, the sulfur dioxide and the nitrogen oxides all got into the air. Sunlight transformed them, made them acids, actually, with the extra energy from the sunlight. And these little acid droplets accumulated water surrounding them, and that made the rain droplets acidic, and it rained on Canada. And that caused problems in Canada. It caused potential damage to buildings and
crops and probably things,
animals and all of that, and streams. Actually, one of the best explanations of acid rain I'd ever seen was in Sports Illustrated.
That's
talking
interesting.
to the fishermen, because it was polluting the fishing streams, and the fish were developing all sorts of mutations. The fishermen were complaining about it.
So I guess it is possible for this.
Yeah.
Since you brought up fish, if I was fishing anywhere near East Palestine, chances are I would not want to eat that fish. I would throw it back.
I would be real cautious about that. I tend to not be a risk taker.
So would it be
kind of in the right field?
So in your mind, would it be worse inhaling or ingesting these chemicals, or about equal?
About equal. It's
equal.
How do you choose your poison?
I know. I was sitting here and I'm thinking, which body part is going to get hit? It's because it's going to get hit.
It's
probably
all connected. If you breathe it in, it can go anywhere in your body. If you drink it, it can go anywhere in your body.
Yeah. Okay. So that answered that question.
Yeah.
So and I definitely want to talk a little bit about. We talked a little bit about the remediation, and I think this is just going to go a while for this. But there are no answers right now for that. We're still in the thick of the beginning of it, I would say. Right. So I guess then if I'm living in Pittsburgh or Cleveland, then would I be concerned still from if I were on well water? I would still be okay.
Yep.
So knowing the area, and for those of you that are watching or watch later, if you don't know the area, bring up a map of the United States. Pittsburgh is close. Cleveland is close, but not as close as Pittsburgh. So it's kind of interesting how far, in my mind, looking at a map, this is going. I guess then let's take a couple questions. If anybody has questions, and while everybody types them up, I do have some. I had a tremendous amount of questions sent to me, and we tried to pick the ones that were the best. So let's go ahead and start the questions. I'll start with ones that were sent to me. Can we get your opinion on the release of combustion byproducts like phosgene and unreacted VCM? And he said, incomplete combustion. Would harmful effects be expected, and how far away? And I should note, you might have answered this. This is coming from a chemical engineer, so you might have answered this, and I just haven't put two and two together yet.
Yeah. Okay. So he's basically digging into details of what I mentioned before. So I talked about the heat of the combustion, some being cooler, some being warmer. And there's a time element too. How long do you let them cook? So they can cook. The longer they cook, the different the chemicals come out as well. So when he says incomplete combustion, that really what he's talking about is, do you keep the steak in and pull it out rare, or do you pull it out well done? It's going to be two different kinds of things from the cooking time. So that's the issue of cooking time. Another complication in there. And that's why all of this list of complications basically says prediction is going to be a little more of a guessing game in many cases, because one, we could not collect enough data from these instances that we could make a good prediction from it. And secondly, it's very complicated no matter what. So even if I had this in the laboratory and I was doing this,
it would be hard too.
It would be hard.
Yeah. And I should point out, I did mean to earlier, one of these hazardous materials is actually used to make PVC that's in a lot
vinyl chloride. Yeah, vinyl chloride is actually fairly infamous. It was they were discovering vinyl chloride monomer workers. So monomer, you may have heard people say monomer. The word sounds a little like polymer. That's because the two things are kind of related. Monomer would be kind of a single molecule. A polymer would be taking a bunch of single molecules and then chaining them together like a string of pearls. Plastics are polymers. They're made one molecule at a time from the monomer. And vinyl chloride, the vinyl chloride that they were taking around, was a monomer. Vinyl chloride monomers are associated with liver cancers from people who were manufacturing these things. A lot of the work was done in Italy, where there was a plant that was well known, and some of the stuff got as well into the environment surrounding the plant, and there were cancers in that area. So it's kind of a famous cancer-causing element or cancer-causing molecule, which we would call a carcinogen. That's basically something that generates cancer.
Okay, let's take a viewer one. So Dr. McCawley, in your opinion, was the controlled burn the best way to take care of that situation with the train derailment? I knew that was coming up. That was tough.
No, it's a complex situation. There's not a single simple answer to a complex situation, but I can explain a couple of the thought processes that go behind it. In fact, I mentioned it before that if you burn it, that's less of it that's going to get into the water, get into the aquifer, and be perhaps more difficult to take care of. On the other hand, if you burn it, you're going to send more of it somewhere else.
Yeah.
And you're going to get more people exposed to it. And it's not going to be what it started out to be. So it could be less toxic from burning it. So if you take an organic chemical and you burn it, in the simplest of explanations, you get CO2 and water. That's great.
That's great.
It's not good to put CO2 into the air. That's the
best case scenario, I guess, of what this would be.
But in most cases, you're not going to get just CO2 and water. You're going to get other complex, maybe a lot more complex molecule coming out of that. That first of all, we may not know what its toxicity is, and secondly, we may not know how much of it we're going to generate from doing that. So there's two sides to the coin. Flip them, and which is the one you're going to be most concerned about.
It was my understanding that the state officials asked for the controlled burn. Do you know if that's typical? Or I always thought that it would have been the federal that would have taken over because of the rails, but with the state, I guess they had more game, more say in the game here because it was in their state and their residence.
Yeah, well, I worked for the feds for a long time, and we tried to get along with the states, strangely enough. And so, yeah, when we come into an area, we want to hear what the people have to say,
Mm-hmm.
particularly the politicians that are in that area who are representing the people,
Mm-hmm.
because they were elected by the people. So if we came in, the local resident or the local politicians, in fact, would say, we'd like to see this done, we'd strongly consider trying to do what the locals were asking us to do, because they were the ones who had to live with the results.
It's my understanding, when this is kind of off topic, but it is kind of talking about the federal and the state. When my child was younger in Atlanta, we went and did a tour to CDC, and I know that you work with CDC, and the biggest shock to me was the CDC has to be invited or asked in.
Yep.
It wasn't that all of a sudden there is, a romaine lettuce issue and the CDC is right there. They have to be asked in. So I kind of felt like maybe this was similar.
Well, yeah, in fact, I can give you an exact example of this. Mount St. Helens, when it erupted, I was working for CDC, and apparently at the time I was one of the few air pollution people working at CDC, and so I got an immediate call. I, in fact, had been at a conference in Texas, and they got up at the plenary session and they said, anybody who knows anything about sampling dust around volcanoes, the state of Washington would like to hear from them. And I looked at the guy sitting next to me and I said, who in their right mind is going to raise their hand and go, oh yeah, I think I'm going to go out and sample around an active volcano. Well, the following week when I got there, it was because CDC had been asked in. And I walked off the plane. There was a reporter down at the bottom of the ramp with a microphone and said, what took you so long to get here?
I have to be asked.
I have to be asked
to come in. So I think it's important to understand that the states have their needs and the federal have their expertise, but a lot of times the states and the areas will ask them to come in. And let's pop up, but Diane had a follow-up question. Are there any statistics out at present time of illnesses to persons related to the chemicals? And I guess that would be whether you worked in a factory or of the chemicals. So I think, and correct me if I'm wrong, Diane, I think what you're headed towards is if there are statistics out there at the time that it existed before this train derailment, this would give the residents an idea of what they're looking at.
Okay, let me see. Yeah, I mean, it sounds like a simple question, but actually there's a whole lot to it. Let me see if I can answer it concisely, at least. For all of these chemicals, I believe, or at least all the ones that were listed on the train, there are safety data sheets. And in fact, the train should be carrying the safety data sheets even with them, so that any responders, if there's something that happens, can look that up. And in fact, actually, for most of these chemicals, when the fire trucks roll up, they got a computer in the truck. They hit a button and up pops perhaps the main hazards are that have been studied. Now, they can be studied a couple of different ways. One is occupationally. So I worked for NIOSH, the National Institute for Occupational Safety and Health. We went out to industries and we studied the effect of exposure on workers. So we'd measure their exposure and then we'd measure their response, and we get these dose response curves, how much they got exposed to, how bad their response was to them. And we could categorize them by what kinds of diseases it caused, and how much material it took to cause that disease, and how long they had to be exposed for doing those kinds of things. Those kind of chemical exposures tended to be on the higher side than they would be for, say, ambient, the outside environment. And so in the outside environment, there are a number of different researchers. And while I talked about working for NIOSH and doing that research, I've done the same kinds of research at a university, and we relied at NIOSH on a lot of university researchers doing these kinds of things. And on the companies themselves, they would keep track. And for a lot of chemicals, when they're produced, there's testing done to see what the effects are and how toxic something is. We produce more chemicals than we can produce data in.
Oh, well, that's an interesting comment there.
It's an interesting thing. The estimates are 1 million or more new chemicals per year, and we can test thousands of chemicals per year. So there's a gap.
There's a gap. Yeah, that's
what we're making and what we know about what we're making.
Interesting. Okay, let's take another. This is another question that came in before the webcast, and again, this is probably on the more technical side. What might have been expected in terms of toxic effects if VCM was allowed to vaporize without being burned? Of course, this assumes that an explosion would not have occurred. And I think we kind of touched on, it was a choice of that or burn.
Yeah.
But I guess with burn, we have a lot of unknowns. Do we have a lot of knowns if we would have just let it burn off?
Well, vinyl chloride monomer, we know a lot about because of the manufacturing processes, particularly in this one plant. It produces a particular kind of cancer that almost nothing else produces. So that was kind of the dead giveaway. It was this one slightly strange form of cancer. And it was only occurring, it seemed, in the people working in the plant. And so when you see something like that, that's a red flag that goes up.
Okay, so then if we would have left that was probably a known effect of those that live nearby.
Yes.
And later on, if you start to see that particular strain of cancer, that would be an easy 1 + 1 = that.
Right. And that it would also tell you this is one of the things you should look for. Okay. So, for example, when I was a small child, I had all sorts of ear problems. And at the time, one of the things that people thought would solve some of these ear infection problems was a dose of radiation. They put an X-ray machine up next to your head, flip it on, and give you a dose of radiation, which would tend to clear up the infection. But as it turns out, it also tended to cause cancers.
Yeah.
Thyroid cancers, in fact. So, and it took a while to figure that out, and they had to do surveillance. I can remember going for testing in my 20s where they said, we're looking for this. And fortunately, never found anything.
Well, that's amazing, though, that was happening.
That kind of surveillance, when there's an exposure, that we say, the first few people that were exposed, we found thyroid cancers in them, so we're going to start looking at everybody that got the exposure, and the word went out. We're going to do this. Same thing was true of the Teflon exposures, right, down in Parkersburg. They first saw it in the cattle, I believe, and then looked around and found it in the population. And in fact, actually, a lot of the people doing that were my colleagues right here in the department that I'm in.
Interesting. That were doing the research for that.
Yep.
So who would, if in a year or two, a certain type of cancer or strain pops up from the VCM, who tests that? Is that your local doctor alerts a federal agency?
The answer is it could be a lot of different people. But yes, we hope that your local physician is going to spot something and say, this looks kind of odd. But the problem with that is what's odd and what is a sentinel event. The other joke that we have, standing joke among our kind, is that an epidemic is something that's so bad even an epidemiologist knows it's happening. You have to collect this data from various places. And so state health departments a lot of times will get reports, well, we saw this cancer and it's an unusual one.
Or an unusual
but we've seen it in several people. That's called a sentinel event. That's the red flag.
Interesting.
That something may be happening. And so the state epidemiologist and the state health department can come in and do an investigation behind that call in somebody like CDC,
Mhm.
or actually the group is ATSDR, the Agency for Toxic Substances and Disease Registry, which is a part of CDC actually, but it's the one that does kind of the surveillance work.
And right now, from the train derailment and continuing right now, data is being collected and stored and analyzed. And as I guess we talked about the air and the fronts and the water and the groundwater, all of that data is being collected and going to be studied and looked at for years to come.
There'll be people turning in grants for years.
For years for that. That's a good point. That's a very good point. Okay, let's see. I think you answered this one, but I'll ask it real quick. But I think because it's a real short one. Do you have concerns about other chemicals being released? I think he meant from this particular event, but I'm going to modify it because this talks a little bit about where I would love to have you come back and talk more about the remediation and prevention of this. So let's change this question to a little bit about prevention. Do you have concerns about other chemicals being released? And let's, I guess, narrow it down to train derailments. We have untold amount of cars, railroad cars, on our rails every day of hazardous materials, non-hazardous as well, but hazardous materials. So the prevention, is there one?
There is prevention. There's engineering controls here. So I taught in the School of Engineering before I taught here in the School of Public Health, because I was teaching environmental engineering, and now I'm teaching environmental health, the kind of the adjunct to all of this stuff. And I taught my engineers something that I think almost all engineers are taught. For any problem, there's a solution, always. It may not be the solution you want. It may not be the solution you can afford. It may not be the solution that makes everybody happy, but there is a solution. And that's true of controlling things. Give me a situation, I can tell you how to control it. You may not be happy about what it costs.
This is tricky too, because I immediately jump from rails to our roadways. And these materials are going to get to where they need to go one way or another. They're not going to fly. They're going to either be on our rails or our roadways, I imagine. So it sounds like maybe a group will maybe get a grant or maybe explore this as a different project. What is the prevention? How do we change this? And this is veering very close into politics. I know that. So I also want to be mindful of that. Instead of he did this, he didn't do that type of thing with our government. But it just seems that we should learn from this.
Yeah, I'm going to quote Pogo, who again, you have to be old enough to remember. And Pogo said, "We have met the enemy, and he is us." We get what we vote for, and we decide. We, the people, really, in a sense, decide how much protection we want, how much risk we're willing to accept. Because the discussion is, well, if you want enough protection so that the risk goes almost to zero, and in fact, the risk never goes completely to zero. But if you want to do that, it's going to cost you more.
I was going to say, this is a money question as well. This is a
voting
question and a money question.
Yeah, and it's a community question, because it's you and your neighbors, me and my neighbors, deciding what we want to pay. And at risk, and telling our officials, we'll elect you if you tell us, we agree with how much you want to pay in this and how much you don't want to pay. And so
I think that's might be a good way to end the broadcast as well. Is there's people have lived here all the time and they probably never really thought about the risk. I know growing up, one of my favorite sounds in the whole world is the whistle of the train. Growing up, that was how I woke up. I didn't have an alarm clock. I had a train whistle. And until this conversation and this derailment, I never considered how close I lived towards near a train and how something like this could happen. So I guess maybe the best way to end this is kind of what you mentioned before we started: prevention. Think about where you live and think about the risk that you're willing to take, the cost and the voting that you've got as well to keep you safe.
Right. As I said, in public health, we're the fence at the top of the cliff.
Mm-hmm.
How much do you want to pay for that fence?
That's a really great analogy. That's true.
Yeah.
That's
And,
very true.
you know, once you tell us how much you want to pay, we'll tell you what kind of fence we can build.
And that fence might be ironclad, like you said. There is not going to be anything that's perfect, or it might be one of those ones that needs replaced.
Right.
So, and I want to agree with Aaron that I do thank you as well, because you did bring the subject matter down. It's a tricky topic for those that aren't scientists or into the conversation. And also what we wanted to do here is not only try and take the politics out, but also the flash of the news and the flash of what's going on and the myths. There are tons of myths. Now there's conspiracy theories that are out there about why this happened. And we wanted to remove all the excess and give you guys just the facts of what is going on. And I really, really thank you, Dr. McCawley, for doing that. It's really needed, I think, for these areas. And like I said, this is personal to me as well. I have family in West Virginia that are there. So this was an important topic, and I appreciate you.
You know, thank you for hosting this, because it gives those of us who are the technical folks a chance to talk to everybody and say, let me tell you what we're saying in these kinds of code words where we get together and talk. Because put a room full of engineers together, you won't understand a word we say.
You're right. It will be completely over. And I haven't warned Dr. McCawley yet, but we do have a major mining series coming up in 2 months. So I might see if I can tempt you to come back and talk about black lung.
That I spent most of my career at NIOSH doing black lung.
So you guys, I might be able to convince Dr. McCawley to come back, and we'll discuss black lung, because again, my ancestors, West Virginia coal miners. So that's something I think that it would be great to dig into a little bit and understand from a genealogy ancestor point. But guess what? It's still there today.
Yeah. And my great-grandfather was an anthracite miner.
So. Really? Oh, that's interesting.
Yeah.
So, So hopefully we'll get you to come back. And we already have one member saying yes. So, so I want to thank everybody for being here today. And we are taking a break next week. We will see everybody back in 2 weeks for our next webcast. And thanks so much. Bye, everybody.